Okay, we need to evaluate the triple integral over Q of 2xy dv, where Q is the tetrahedron formed by parts of the xz plane, the yz plane, and the xy plane. And the tetrahedron has vertices. Well, this vertex here is 2, 0, 0. This one is 0, 1, 0. And this one is 0, 0, 4. And then the one in back at the origin is, of course, 0, 0, 0. Okay, so then there's this plane face that's formed, a plane face of the tetrahedron formed by these vertices, the 2, 0, 0, the 0, 1, 0, and the 0, 0, 4. And in order to find the limits of integration, the inner limits of integration, we're going to need to find the equation of this plane that I've shown you in red here. So how do we do that? Well, it's actually, there's a pretty easy trick to it when we're given the x, y, and z intercepts. So here's the trick. The equation of a plane, any equation of a plane, can be written in the form ax plus by plus cz equals d, where a, b, c, and d are constants. Now, if you know the intercepts, multiply the numerical parts of the intercepts together, the non-zero parts I mean. So the 2 times the 1 times the 4, and call that d. So that's 8. So replace d with 8. And of course, that gives us ax plus by plus cz equals 8. Now, if you think about it, in order to get an x-intercept at 2 on the x-axis, well, think about how the x-intercept is created. You'd plug in 0 for y, or think about how it's found, not created. You'd plug in 0 for y and 0 for z and just end up with ax equals 8. In order for that to be, in order for the x-intercept to be 2, a would have to be 4. So in a like manner, so you get a equals 4. In a like manner, you could, for instance, plug in x equals 0 and z equals 0, get by is equal to 8, and which would mean b would have to equal 8 in order to get an intercept on the y-axis of 1. And then in order to get a z-intercept of 4, c would have to equal 2. So what does that mean? Well, that means the equation of that plane is 4x plus 8y plus 2z is equal to 8. Or if you go ahead and divide by 2, you get 2x plus 4y plus z is equal to 4. And it would be nice to solve for z. So if we do that, we get z is equal to 4 minus 2x minus 4y. So the equation of this guy right here is z equals 4 minus 2x minus 4y. And so to get the inner limits of integration, put in a vertical column. We're integrating with respect to z first, from the xy plane up to the plane in red, and the bottom of that column gives you the lower limit of integration, the top of that column gives you the upper limit. So it goes, the inner limits of integration go from 0 to 4 minus 2x minus 4y. To get the other limits of integration, project this this top plane, well, I call it the top plane, the plane in red, straight down, and you'll land on this triangular region in the xy plane. And if you draw that, you get this region right here. Whoops. Okay. Now, we'll go dz, dy, dx, so using vertical rectangles as a model. Let's set up our integral. We already know that the inner limits go from 0 to 4 minus 2x minus 4y. The equation of this line right here, well, if you think about it, the slope has to be negative 1 over 2, and the y-intercept is 1, 0, 1, so its equation is negative 1/2 x plus 1. And so the inner limits go from 0 to negative 1/2 x plus 1. X goes from 0 to 2, and that's your setup. It's straightforward to evaluate. I'll let you do that. I think you should get 4/15 if you evaluate that interval.